Okay, this is Phys 2320 Computing 2, and this is the second video on matplotlib. So in the previous video we just did a very quick introduction to plotting things. So matplotlib.pyplot contains the lots of the plotting functions we're going to use. So conventionally we would import this and call it plt, PLT. So you would do import matplotlib.pyplot as PLT, and then your basic plotting command is simply plot x data, y data, and then an optional format. And the format is just a very quick way of specifying how the plot should look. So typically there's a letter to describe the colour, so red is R, green is G, blue is B, yellow is Y, black is actually K, because B is already taken. And then the second thing is something that describes either the markers or the lines. So an O becomes a red circle, greater than and less than signs give you triangles, pluses give you crosses. If you do a minus, then you get a line, and you can do things like dot minus to get dotted lines or dashed lines and things like that. Then there's a plt.title, which lets you add a title to your plot, and a plt.x label to add an x-axis label, and a plt.y label that adds the y-axis label. When you do the plot, if you have an optional keyword parameter label, then you can basically give each plot you do a name, and then if you do plt.legend, then you're going to get a legend on your plot. So we're going to do more on matplotlib now and just show you a variety of new commands. Okay, so to start with, what I'm going to do is I'm just going to go and create a bunch of data. And in fact, what I'm going to do is I'm going to create a data with a Gaussian peak, and I'm going to make use of the SciPy stats module, which has this norm thing in it that I can use to create a Gaussian distribution or a Gaussian plot. I also need to import NumPy, and I'm going to import matplotlib.pyplot. So I've just created some X data. That wants to be np.linspace. And then I'm going to create some Y data, which is just a million times the PDF is the probability distribution function. So if I just open up on that and see if I can persuade it to give it to me. There we go. So PDF takes a lot of X values, and then it takes things like the location of the peak, so the position of the peak, and then the scale, which is the width of the peak. So that's just going to be some XY data. So the first thing we're going to do then is we're just going to go and plot that data. So nothing new there at all. So run that, and I'm going to pop my plot up there. So that's what it looks like, and hopefully that convinces you that that's a Gaussian distribution. Now actually we should unpack what plot has gotten done. It's in fact done a whole bunch of things for you in one go. So the first thing it did is it created this plotting window, which got the label figure 1. And then within that plotting window it created the axes, so in other words the frame of X and Y coordinates. And then and only then did it go and draw that Gaussian peak inside it. And actually in matplotlib that's 3 separate things that plot will take care of for you, but you can run manually. And the advantage of running it manually is it gives you more flexibility and more options. So for example, if I call plt.figure, so what figure is going to do is it's going to create a new figure window, or alternatively it's going to refer back to a previous figure. So if we look at the description of the help here, you see the first parameter it takes is a num. So when I create a figure, I create a empty window. So there we go, and you see that what it's returning back to me is a thing that's going to refer to that figure. It's actually creating a variable which is that figure. There we go, it's a blank window. You see it's called figure 1. If I create another figure window, oops, down here, plt.figure, let's give this a fig size. That's one of the more useful options. So let's make it 6 by 4 inches. So there we've created this. Now we've got figure 2. You see they are different sizes. Okay, so if I now call plot, what it's going to do is it's going to plot things on the last known figure. So in fact, let's first of all go and create a set of axes. So let's do plut.axes. And again, you see on the help here, it gives you a whole bunch of things you can go and do. You can go and change the color, you can go and change the aspect ratio, you can even make it share settings between different sets of axes, you can create polar plots, you can do all kinds of fancy things. We're going to just create a set of axes. So there we go. And again, you see actually that's returning back to us a thing which is an axis. So figure 1 is not done anything. Figure 2 is drawn a set of axes. If I now want to add a set of axes to figure 1, what I could do, so I can say, okay, let's switch back to figure 1 by calling figure again and now giving it num equals 1, or just passing it 1 as the first parameter. So that's now made figure 1 my active figure window, and I could create a set of axes there as well. And so what we could go and do, then we can go and say let's create a set of polar axes here just for fun. So we go back to our window, figure 2 still has our rectangular ones, and figure 1 now has a set of polar axes on it. Okay, so that's fine, and we can get that data and it can plot on either of those two windows. So let's go back and work again with figure 2, and we're going to then now go and add our plot to it. So I can go back, plot.figure 2, switch back to figure 2. Figure 2 is now my active plot, and we can now do plot.plot xy. And there we go. Now you see when I do the actual plotting thing, that's when it goes and sets up the axes to have the right limits and so on it. Okay, so that's using figure to create the figure windows and to switch between different figure windows. If you need to work out which figure you're on, there's a handy plut.gcf function which simply gets the current figure. And in the IPython console you see it just replots it. So that actually gives you a thing you can catch hold of. So fig2 equals plut.gcf. So, and then if you have a look at all the things you can do on figure 2, you can see it's got a whole bunch of things you can do with it. We should have somewhere number, which comes back and says it's figure 2. So you can work out which figure you're on with the GCF plot. Okay, so you may have seen there that one of the things it looked like we could go and do is create different plots within the same figure. So let's just show you that one. So let's do plut.figure just to create a new figure window. I've closed all the ones down. So there we go. And now I'm going to make use of the subplots. Plut.subplots. Now this takes a number of different ways of specifying things. You can either specify a number of rows, a number of columns, and then which subplot you're on. There's a shortcut, however. So I've got that right. No, sorry, I wanted subplot. There's a shortcut you can do which does something similar with subplot. So subplot, you can either specify number of rows, number of columns, and a plot number, or you can just specify that all as one number. So for example, if I specify 221, what I'm saying is create, so this is subplot 221, I'm saying create more than one set of positions for axes within that figure window, create 2 rows, 2 columns, and start working with the first one. So I do that. I still won't see anything on. No, it's given me a set of axes there. So it's given me the first set of axes there. If I go back and now ask it for 222, it should now have created the second one there. And plot subplot, you can have 223. And of course finally 224, like so. So that's given me 4 different sets of axes. Now again, how do we know which one we're working on? Well, if I simply just go and recall the previous one, so I go back to 221, I could now do plot xy, like so. Okay, so I don't have to just go and plot things on linear scales like that. I can do other options. So of course with the Gaussian peak, what you might want to do is plot things on a semi-log, so a log y axis. So here's one way you can do it. So what we're going to do is we're going to switch to the next subplot. So I've now switched over from this plot to this plot, and now what we'll do is we'll do plot.semilog y. So this works just like the plot function does, except that it now takes things and creates it on a log y scale, like so. And we look at it. Now you look at that and you go, hang on a second here, how is this data and this data the same thing? Well, of course, the problem is if you look at these numbers here, it's going down to 10 to the minus 33, 10 to the minus 25, you're getting really, really small numbers, and that's because, of course, it's getting very, very, very close to 0. So that's not very helpful. We actually want to maybe chop this scale off and look only at a region where it's not quite so small. So we can do that with plot.ylim. And so this simply goes and takes the lower limit and the upper limit. So we could say the lower limit should be 1e to the minus 3 there, and the upper limit could be 1e to the plus 3. So in other words, between 1,000th and 1,000. Okay, and it comes back and tells us what we just set. So now if we look at that, you can see, okay, right, it's rescaled this. Oh, but we're not. We've clipped the top there. You can see this actually goes up to the 8,000. So maybe that should have been 10 to the 4. That's easy enough to do. We can just change the limit again. And there you go. So that's now showing the same data, but we're chopping it off at 10 to the minus 3. And you could do something similar with the x limit. So we could say, let's just look at the data from, say, 400 onwards. If I just call plot.xlimit without any parameters, it tells me what the current settings are. So it's saying it's going from minus 50 to 10,050. So what I can do is I can do, let's do xmax, comma, xmin. No, wrong way around. xmin, comma, xmax equals plot.xlim. And now I can do plot.xlim, and let's change that to 400 and xmax. And there you go. So now I've changed the x-axis as well, and so I've gone and zoomed in on a log x plot. And of course you can do the similarly things as well. We can switch and plot. So let's go to 223. And let's do plot.semi. In fact, let's go for the whole way. You can obviously do a semi-log x, which gets you a log x scale, linear y scale. But the other one you might want to do is a log. There we go. Again, it looks a bit weird, but we could concentrate by zooming in to a certain level, or we could just leave it like that. So there's all the same data, just plotting. That's a semi-log y, this is a log. I suppose probably for completeness we should do a semi-log x. Let's just go and do that then. And there you've got the complete set. So I'm using xlim and ylim up here to go and zoom into a certain plot. This is a semi-log y, this one here is semi-log x, this one here is log, and this is just normal. Okay, let's go and close that down again. Let's just go back and just do a straightforward plot. Okay, so you do the straightforward plot and you go, oh no, I did that wrong. I meant to go and have a log plot or a semi-log y plot instead. Well, we can go back and change it. There is a y scale, plot.y scale, and again this now gives you options to go and adjust settings on the y-axis after you've plotted things. So as you can do, you can see you can go and change between linear and log scale. And if you plot on the log scale, you can also specify the base you're plotting to, so whether it's 10 to the power or e or whatever, and you can also go and specify how you handle things where it lies outside of the visible plotting. There's a number of variety options there. Not all of these are available in all versions of SciPy, but linear and log are available in everything you're going to come across. So let's just change that to log. Whoops, try log, not kig. So I should say, of course, remind you that we always encourage you to go and look at the documentation. So the documentation on matplotlib is really quite good. There's lots of things you can play around with. And you're very much encouraged to go and look at things online to work out how to do stuff. In particular, the official documentation for SciPy, NumPy and matplotlib is all free game. Okay, so the x scale then will let you go and will let you do the same with the x-axis. So I can turn that to a log plot simply by doing plot.xscale log, like so, and there it goes. And then you might say, okay, let's see, I don't particularly like that set of markers. So we've got going from 10 to the 1 to 10 to the 3, but we can maybe get some other ones in the gap here. So how can we look at that? Well, we've got xticks. So xticks goes and lets you mess around with the markers. And you can do things like you can rotate them, you can specify fonts, you can give it a mapping, so we can give labels at certain positions. There's quite a lot of things to do. Let's just go and do something fairly simple. We're going to do log space from, let's do 0 to 3 with 7 points in between. So you see it goes and creates a whole bunch of xticks, and has it managed to go and do that? Let's make sure we redraw the graph. So plut.draw tells it to update things, and it should have updated us with extra major ticks in there. Okay, so xticks lets you go and update the way things are ticking, the ticks you've got on the axis, and yticks does basically the same thing. Okay, if we go back, let's close that figure again. So that's messing around with changing the axes between linear and log, changing around with the x scales, changing around with the limits, obviously labeling the axis we've shown on the previous video. The other big thing you might need to go and do is go and have some error bars on your data. So let's first of all just go and generate some error bars. So let's have a fixed x error bar. So that is simply going to be create a array of ones that's the same length of x, and let's multiply that by 50. So we're going to have x error bars that are 50 plus or minus 50. Whoops. And that should be okay. And y error, and there, let's make something which changes the size of y. So let's do y over 100 plus 400. Let's try divide by 100. Okay. So the plotting with an error bar makes use of the error bar function. Take that, you'll see it takes x, y, and takes y error, x error. It then takes a format keyword, which is the same as the format used on the regular plot, and then it takes a whole bunch of extra options which allow you to set details about the way the error bars are actually drawn. So let's give it x, y, x error equals the x error bar, and y error equals the y error bar. And then one that I find helpful is to have cap size, to give a nice little cross on the end of its error bars, and there we go. So if we run that, there you get an error bar plot. So you see maybe our x errors are a bit big, and our y errors we could make a bit more variable in size, so we can easily just go and change that. Let's just go and change our x errors to be 10 plus or minus 10, and let's make our y errors change a bit more. So there you go, I've just made the error bar smaller. If we zoom in, then you see that as we go up in y, those error bars are going to get bigger and bigger and bigger, as I specified, until the ones at the top have a reasonably large number. So I've not specified a format, so it's just drawn straight lines between the sections. Now again, a little bit of kind of way you present data thing in here. You should only really go and draw lines on graphs if something is a continuous variable, if you know that something's a continuous variable. If you have points with an error bar, it's probably because you've been measuring things, and therefore you might think that actually you've measured here and you've measured here and not anywhere in between. So probably those things should not have a line drawn between them because these are individual measurements. So in that case, we probably ought to specify a format. So let's have green circles. So when I draw that, now the error bars of course are a bit on the small side, but if I zoom in, then you can see I've now got green circles with the error bars. And again, in reality what you'd do is you wouldn't draw error bars if the error bars were smaller than the data points. And quite often in physics that is the case. If we have green dot, then I simply make the error bars smaller, and now you can see, now as I make the point smaller, and now you can see the error bars standing out from around it. So that's just simply using the errors the error bar plot to go and set the error bars, and you can get quite sophisticated there. You can make this be have separate errors for the for going positive and negative away from the data point, and you can make it, and likewise with the x and y, you can have asymmetric error bars. But generally speaking, a lot of the time you're going to find that symmetric error bars, so plus or minus an error, is what you've got in your data. Okay, so then there are lots of other functions. There are various contour and surface plots. I'm not going to go and show those now, but again, read the documentation, because there's an awful lot of stuff in the documentation. But that just gives you at least a set of simple ways of plotting. So the final thing I wanted to show you then was how to annotate your plot. So let's just recreate our plot, and now let's go and put some, first of all, put some text. So we've got a nice big gap here, so let's go and put some text in, say at 200 by 4000. So to do that, it's very simple. It's plut.text, and then you see it takes the x position, the y position, and then the string of text you want to put in. It then takes a whole bunch of information about the fonts, which is optional, and then you can also do things like specify whether you're giving your coordinates in units of the data or in units of the figure. By default, this is the data. So we wanted to put that in at 200 on the x and 4000 on the y, and say, here is some text. Okay, so there you go. We put some text on the plot. Of course, more normally what you might want to go and do is to actually highlight a particular point on your data set. So you put text in here if you say had fitted something to this data and you wanted to put the fitting parameters onto your graph as well to make it all in conveniently in one thing. But the other thing you might want to go and do is actually point out a particular data point. So that you can do with the annotate. So first of all, what we're going to do is we're going to find the coordinates of the highest point in our data set. So I'm going to call that y max, and that is simply the biggest y value. And then we want to find the x coordinate that corresponds to that biggest y value. So in that case, what we're going to do is we're going to do x, and we want the x coordinate that corresponds to the row of the coordinate at which the biggest value is. So if I bring up the help for argmax there, then what you see it tells you is it returns the index of the maximum value, and long given axis is only applicable if you've got multiple dimensions. So in other words, this is telling you which row of the array of the y values has the biggest value in it, whereas y.max is telling you what is that biggest value. This tells you where it is, that tells you what it is, and then I want the corresponding x value. Okay, so that's the two coordinates. So you can see there y max somewhere near 8000, and x max is at 700, which is where I told it to go and create the peak. So that's all good. So plut.annotate is our friend here, and again, see if we take the help here, it's going to take the message we want to put there. It then is going to take as a list or a tuple the x and y coordinates of the point we're interested in, and then the x and y coordinates of where the text should go. So the text doesn't have to go where the point you're interested in is in. So let's add that in then. X max, y max. So I'm making those a tuple, so they're going to round brackets. And now I need to specify where the text is going to go. So let's have x max minus 500 and y max plus 200. Okay, and then of course what we want to do is have an arrow or something pointing at it, and if we carry on down, then eventually get to arrow props as a keyword parameter, and it says here arrow props does not contain the key arrow style, then you can fine tune the details of the arrow. Alternatively, if you give it arrow style, you can tell it very quickly how the arrow should look, and it goes and works it all out. And you see basically it's almost like a little picture of what it should look like. You also specify things like fancy, simple, wedge, and so on. So in fact I'm just going to go and do the simplest dash and so on there. So arrow props, props equals, now you see this is a dictionary, arrow style, there we go, close the dictionary, close the annotate, and there we go, and let's have a look, and there you go. So it's drawn the text, and it's where I told it that I backed it off by 500 and moved it up a bit, put the text there, and it's drawn an arrow in. And of course I could have played around with the specification of the arrow quite a lot as well. So that's then annotating a particular point on the graph. And of course you can give it any XY coordinate you want to. So I mean I could have just annotated a random position at say 500, 3000. So there's nothing special at 500, 3000. It's just a random point I'm picking, and let's put the text in at 600, 2000, and let's have arrow props equals, and we'll have arrow style. Let's see what fancy does for us. So there you go. There's a random point and pointed to with a fancy arrow. So again, you can have a lot of fun just randomly labeling things up like that. The point is that the annotate just simply points an arrow at some random position. It doesn't have to lie on your graph. Okay, so I think that's probably enough to keep you going. As I said, you can go on and you can explore the documentation of matplotlib. You can change lots and lots and lots of things on your graph. You can change fonts, you can make fonts spin round, you can do lots of kind of crazy things. You can make it look like an XKCD cartoon if you really want to. You won't get extra marks in your coursework if you do that, but you can make things almost infinitely adjustable if you just tinker away with it. So in summary, I've shown you plot.figure, which creates a new figure window or lets you switch between different figure windows, has a very handy figure size keyword parameter that lets you set the size of the plot window. I did plot.axes, which created new axes. I did plot.semilog y, semilog x, and log, and also plot.errorbar. That should be subplot singular, goes and creates more than one set of axes that you can go and do on a plot. Then x scale and y scale let you go and change whether you're scaling between linear and log after you've done the plot, and likewise xlim and ylim let you change the limits of the plotting for the x and y axes, and plot.text and plot.annotate let you start writing things over the top of your plot as well.